Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, I'm going to show you how to evaluate 129 different trigonometric expressions. And yes, I am serious. We are going to work through all of these examples. Now, I tried to do my best and find every single unique possibility of these angles, and I didn't do obviously all of them because there's infinite many angles, but I'm going to evaluate a lot, and I'm going to do that without evaluating the unit circle. Now, obviously, to do all these, we are going to not work, we're not going to create the unit circle for every one of these problems, but basically the way that I teach my students is to make sure that, you do need to have the first quadrant understood. So we are going to utilize the first quadrant. And again, I am going to work through some of these problems as a little bit of an introductory basis for those students that are relatively kind of new to evaluating trigonometric expressions for angles using the unit circle. But I am going to kind of show some of my shortcuts, because obviously if I'm going to be working through these problems, step by step, every single one, it's going to take way too long. So I think the first thing is we need to make sure we understand the unit circle here. So exactly the angles that make up the unit circle. So the first angle, pi over 6. And then we have the coordinate point, square root of 3 over 2. Already making some mistakes. Comma 1/2. All right, and I'm actually going to refer to this as well because I already know I was creating, looking at the key for this. And I even had to stop doing the key because my brain hurt. So this is going to be a fun video to be able to kind of work for this. The next angle here is going to be for pi over 4. And again, if this is something that is too advanced, for you, then obviously I have many other videos that is going to, work my way up to why I'm getting these angles, where these points are coming from. To give you the short answer, it's using special right triangles, basically are being laid on the coordinate grid system, and then a unit circle is or a circle is basically connecting those points. But again, I don't want to overcomplicate things for people from in there, because basically, if you're watching this video, we are at the point where you're like, all right, I understand the unit circle, I understand these points, I just need to know how to evaluate these. So a couple things is we need to know the first quadrant. I think the other one that's important is when there's actually not a triangle present, it would be on the axes and knowing these coordinate points. Sometimes we get these points mixed up. So I think it's just important for me to write them out so I don't mix them up. Okay, and then let's kind of do our trigonometric definitions for points on the unit circle. So just remember that the sine of an angle theta is equal to x. Cosine of theta, sine of x is not equal to x. Sine of an angle is the y-coordinate. Cosine of the angle is equal to the x-coordinate. And tangent of the angle is going to be the y over the x. And again, these are for trigonometric functions or for angles that angles that have a point on the unit circle. And then we can use our reciprocal functions. Cosecant of theta is giving me 1 over y. Secant of theta is 1 over x. And cotangent of theta is going to be x over y. All right, a couple of things I think is also important. So, let's do the tangent and the cotangent. I think tangent for pi over 4 is easy. That's going to be 1. But for tangent of pi over 6 is going to be 1/2 the y-coordinate over the x-coordinate. And that's going to simplify. I'm just going to do this problem first. To square root of 3 over 2. All right, and then I'm going to evaluate the tangent of pi over 3. And tangent of pi over 3 is going to equal square root of 3. Okay, and that's basically square root of 3 over 2 divided by 1/2. So I think this is the basics information that I want to go ahead and have. For the first maybe 12 to 15 problems, I'll probably explain exactly what I'm doing, show you how I'm getting these points, and kind of the process that I ask my students to do it. But then obviously, guys, if we're going to tackle 129 questions, we're going to want to get into this quickly as we can. However, so let's go ahead and get started. The first angle, cosine of pi over 3, that is in the first quadrant. So you can see that the cosine of pi over 3, the cosine represents the x-coordinate. So therefore, that's just going to equal 1/2. For sine of 3 pi over 4, we got to understand that, so I'll break this one up simply here. So we understand that halfway around a circle is going to be pi, all right? So that was another thing to mention here. So that would be pi, and actually we should know that half of a circle here, that was pi halves, and this is your coordinate point 0, 1. Okay, so for instructional purposes, you can understand that half of a circle is going to be pi. And based on whatever question, whatever question I'm giving you, whatever the fraction is, you can always break up pi into that many sections. So for instance, we have 4, we can break it up into 4 parts. And therefore, I'm just going to be traveling 3 parts of there. Now, the important thing is when we're looking at this is when I'm going to be evaluating these, especially when I'm going to do them in my head, I am identifying what we call the reference angle. Basically, how far is that angle away from the x-axis? So the reference angle in here is going to equal pi over 4. Because again, halfway around the circle is pi in radians. I just traveled 3 pi over 4. I need to get to pi over 4 more to get to my x-axis. The important thing about the reference angle is the value, the absolute value of the reference angle is equal to the absolute value of your original angle. Meaning that sine of 3 pi over 4 has the same value as the sine of pi over 4. The only difference would be the sign as far as what quadrant it's in. So we need to identify the quadrant, which is in the second quadrant. And the second quadrant means that sine, the y coordinate, is going to be positive. So rather than trying to think of memorizing the unit circle, like what is over here in this second quadrant, I'm just going to evaluate the sine of pi over 4. The sine of pi over 4 is the y coordinate. That's square root of 2 over 2. Since my angle is in the second quadrant, then it's going to be a positive. Let's do another one here for tangent. Now again, tangent is very important because you can see that tangent is not very fun. Like we do not like to simplify these. That's why I kind of did these two ahead of time so I can use them just to once my brain goes to mush. But let's go ahead and graph this. So again, we know that pi is halfway around a circle. Now you can break this up into 6 parts, but my angle is 7 pi over 6. So that's going to be an extra pi over 6 past the x-axis. So therefore, my theta prime in this case is going to be pi over 6. Again, theta prime is your reference angle. It's how far your angle is away from the x-axis. In this case, my angle is in the third quadrant. So I got to understand, is tangent going to be positive in the third quadrant or negative? And again, since tangent is y over x and y and x are both negative in the third quadrant, tangent is going to be positive because negative divided by negative is positive. What am I trying to think? So therefore my tangent is going to be positive, but rather than trying to memorize what tangent of 7 pi over 6 is, I'm just going to do the tangent of pi over 6. Now, you might not say, well, how'd you get square root of 3 over 2? And that just really comes into a little bit of algebra, guys. But if you just kind of multiply, simplify this, you basically doing this, I multiply by the reciprocals, rationalize the denominator. We don't have time to go over that in this video because I do it in plenty other videos, and that is not square root of 3 over 2. That is square root of 3 over 3. But you can see that answer is going to be square root of 3 over 3. Now let's get to one where actually the sign is going to change. So we're going to do the same thing. Hopefully you guys can understand then if here is pi, then all the way around the circle is 2 pi. Or 12 pi over 6. So therefore my angle is all the way around except I'm at 11 pi. That means I am pi over 6 short. So that is going to be my reference angle. So my reference angle, again, is how far is your angle away from the x-axis. And in this case, I am at pi over 6. So again, it's the same angle here, right? It's just the same reference angle. Now the important thing though is my angle is in the fourth quadrant. So that means sine in the fourth quadrant, if you look down at the fourth quadrant, sine is the y coordinate. Below the x-axis, sine is negative. So let's go ahead and figure out what sine of pi over 6 is first. So sine of pi over 6 is the y coordinate, which is 1/2. But since we're in the second quadrant, the fourth quadrant, it's going to be a negative. So that's how you can see how we use the reference angle, but then based on the angle that the quadrant that my angle lies in, I can determine the sign if it's going to be positive or negative. Let me just work on a negative angle. I'll just kind of I'll work through 10. I think working through 10, that'll give us a good idea. And then after 10 examples of doing this the slow way, I'm going to start picking it up. Okay, so remember tangent of, because also I don't want to keep on scrolling up and down, even though I'm going to have to eventually. So tangent of pi halves is going to be, again, remember that's the y coordinate over the x coordinate. Well, in this case, pi halves is right here. So y is 1, x is 0. Well, you can't divide by 0. That's going to be undefined. So this is UND for undefined. For negative pi over 6, let's just graph that. Well, negative pi over 6 is just going down here. So the nice thing here is that is also my reference angle. So my reference angle is pi over 6. So again, I go back to saying, hey, what's pi over 6? Square root of 3 over 3, right? But it's in the fourth quadrant. Remember, in the fourth quadrant, y is negative, x is positive. So a negative divided by positive is going to be a negative. So therefore, that's a negative square root of 3 over 3. Tangent of 2 pi, again, all the way around the circle is pi. So then halfway around the circle is pi. All the way around the circle then is going to be 2 pi. All right, and then at 2 pi, we're looking for this coordinate is 0 over 1, so y over x. So 0 over 1 is just 0. For number 8, I did a lot of 6s on this one, and sine, but I guess that's just how everything comes up. So we're going to do negative 5 pi over 6. Again, halfway around circle is pi, which is also the same thing as 5 pi. It's also the same thing as 6 pi over 6. Okay, so 6 pi over 6 is equal to pi, right? Because 6 over 6 is 1. So we're at 5 pi over 6. So therefore, my reference angle is how far, again, away from my x-axis. I can say that theta is going to equal theta prime, is equal to pi over 6. But I can evaluate the sine of pi over 6, which I already did here, which is, where's sine of pi over 6? I thought I did it. Yeah, right there. Sine of pi over 6, which is 1/2. However, this example, kind of like this one's in the third quadrant. So again, it's still below the x-axis, so it's going to be negative. And again, that makes sense. Like for these two angles, right? This one's in the fourth quadrant, has a reference angle pi over 6. This one's in the third quadrant, has a reference angle pi over 6. And if you look at like a printout of the unit circle, you'll see that they both are negative 1/2 for the y coordinate. All right, last but not least is just understanding when we're doing these, because I have a lot of students, when they're learning this, they want to count. And I have nothing wrong with counting, but when you're doing 129 questions, it's just not a good use of our time. So I'm going to show us an additional way to do this, which would be the using period as an aid. So let's do the counting method first so we can see how that's not a good use of our time. So the counting method is basically taking the unit circle and breaking, that's horrible, but whatever, breaking pi up into thirds. Okay? And then basically we're just going to count until we get to 13 pi over 3 and see where that angle is. So, 1 pi, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8. Oh, come on. Let's try this again. It's like trying to be nice to me, giving me like some thinking here. So pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. No. All right, that's not going to work. So let me try this maybe in a different color so therefore I can get a little more expansive. Okay, so pi over 3, 2, oh my God, pi over 3. This is not what I need from you right now. So pi over 3. Pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3, 5 pi over 3, 6 pi over 3, 7 pi over 3, 8 pi over 3, 9 pi over 3, 10 pi over 3, 11 pi over 3, 12 pi over 3, and 13 pi over 3. There we go. So I had to go around, but you can see like how much of a waste of time was that for me to go all the way around. Either way, you can see that I am going to be, again, my reference angle, theta prime, is going to be pi over 3 away from the x-axis. So some people need to go ahead and graph it out. And again, when you're like just learning this out, that's perfectly fine. But some people just need to graph that to be able to identify what the reference angle is. Because obviously 13 pi over 3 is not on the unit circle. And I think this is my big point, and this is a great kind of question. Actually, I'll do one more negative because I haven't done many negative ones. But this is a great question to kind of like reference why I don't memorize the unit circle. Because 13 pi over 3 is not on the unit circle. You need to know what 13 pi over 3 is equivalent to. And rather than, trying to graph it and figure out an angle, another thing we can look at and identify the unit, the reference angle would be to write 13 pi over 3 as using a period as an aid. So basically what we're going to do is every single time we went around that circle, we started back to where we were at, right? Once we went around, we were like, that was just a revolution. It was an extra thing. So how far is all the way around the circle? Well, yeah, it's 2 pi. But to write that in terms of thirds, that's 6 pi over 3 plus 6 pi over 3 plus 6 pi over 3 plus 6 pi over 3 is 12 pi over 3. Oh, so then I didn't do this right. So I was counting really fast, so I did that wrong. Dang it. Man, that's a bummer. All right, let's try this again. 1 pi over 3, 2 pi over 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yep, you're right. I was wrong. So actually my reference angle, though, still is going to be pi over 3. Okay, so then that's going to be plus pi over 3. And again, you can see that we are back in the first quadrant. So now I just need to figure out, well, what is the cosine of pi over 3? Because the important thing about this is when you do a revolution, that 6 pi over 3, that doesn't change anything, right? So we can just like eliminate those. We just really need to care about this pi over 3, and the reference angle pi over 3 is pi over 3. So the cosine of pi over 3, which is in the first quadrant, let's go back up to that real quick. The cosine of pi over 3 is the x-coordinate, which is 1/2. Okay, and then the last one, guys, I think negative 4 pi over 3. Let's just do one more here. Again, we can go all the way up for halfway around the circle. Again, we're going in the negative direction. So therefore, the reference angle halfway around the circle is pi, or negative 3 over negative 3. So we're going an extra pi over 3 in this negative direction. But the main thing, guys, is our reference angle is pi over 3. Reference angles are not positive or negative, okay? So therefore, we're looking for, well, what is the sine of pi over 3? So we go back up. We see the sine, which is the y-coordinate, is square root of 3 over 2. Since it's in the second quadrant, we can see that it's positive. So therefore, we can say the square root of 3 over 2. All right, guys, I am now going to start just working through these as quickly as I can. So I know I spent like a good 15, 20 minutes really like teaching. And now I'm just going to kind of do some rough teaching. Sometimes I'll sketch the angle. Sometimes I'll just label the reference angle. Sometimes I'll give you the coordinate point. I don't know. We're going to see how this goes. But I got 129 of these to go. So let's go ahead and get started, see how we do. Let's see. This coordinate point here is negative 1, 0. So y over x is 0. Let's see, the reference angle of negative 5 pi over 3. So negative 6 pi over 3 is all the way around the circle. So the reference angle here is just pi over 3. That's going to be square root of 3 over 2. Cosine of pi over 6, that's going to equal square root of 3 over 2. 5 pi over 6 is going to be in the second quadrant, so that's going to be positive. That's going to be equal to 1/2. 5 pi over 4, tangent of pi over 4 is 1, because square root of 2, if you look over here. So we like tangent of pi over 4. That's nice. I just recognize that that angle is going to be in the third quadrant, so therefore that's going to be a positive 1. 7 pi over 4, that is going to be in the fourth quadrant. So therefore sine is going to be negative. So that's a square root of 2 over 2. And again, you guys can follow along with me on the unit circle. Hopefully check all my work. 7 pi over 3 can be rewritten as 6 pi over 3 plus pi over 3. So basically I'm just figuring out what is the cosine of pi over 3. And again, that's going to equal 1/2. Cosine of pi halves, again, that coordinate point is 0, 1. So the cosine is 0. Tangent of negative pi over 4, again, tangent of pi over 4 is 1, but since that's in the fourth quadrant, that's going to be a negative 1. Sine of 3 pi, so, you know, here's pi, 2 pi, 3 pi. So that's going to be at the coordinate point, negative 1, 0, so that sine value is 0. Cosine of negative 2 pi over 3, that's going to have a reference angle of pi over 3. Make sure you also note that that is in the third quadrant. So the cosine of pi over 3 is going to equal 1/2, but since it's in the third quadrant, that's going to be negative. Cosine of 0, again, that has a coordinate point. No, it doesn't. That has a coordinate point of 0, 1, so the cosine of 0 is actually 1. Tangent of negative 7 pi over 6. Remember, the tangent of reference angle pi over 6 is square root of 3 over 3, right? So we just really need to figure out the quadrant that this is in, because the reference angle is going to be pi over 6. The quadrant that this is in is going to be in the second quadrant. So therefore, that's a negative square root of 3 over 2. Negative 7 pi over 4, that is going to be in the first quadrant, so sine is positive, so that's square root of 2 over 2. And again, like, one thing I'll mention to you guys is like the reference angle here is 4. This does not have reference angle. I guess I'm going to write down the reference angle here for a couple of them, as long as you guys have it. So reference angle here is pi over 4. So what you can notice is basically whatever the denominator is, that is going to be my reference angle. Okay, and that's like a little pattern that I wanted you guys to come up with that I didn't like kind of always talk about. So cosine of negative pi halves, that's going to be at 0, negative 1, so the cosine is 0. So here I have pi over 3 is my reference angle. That is 7 pi over 3 is going to be in the fourth quadrant. It is over then, it is greater, or the whole revolution is 6 pi over 3, so it's an extra pi over 3, so that's why it's in the fourth quadrant, and the tangent of pi over 3 is, so that's a negative, and that's going to be negative square root of 3. I think that's right? Did I have the tangent? Pi over 3? Yeah, pi over 3. Yes, that's correct. Okay. 5 pi over 6, that has a reference angle of pi over 6, and that is in the second quadrant. So the cosine is going to, since cosine is negative in the second quadrant, that's a negative 3 over 2. Sine has a reference angle of pi over 3. Do you kind of see how redundant it is finding the reference angles? Because what I'm doing is I'm identifying the reference angle, which is very easy to find. I'll do the reference angle for the rest of this. So then I'm identifying the reference angle, or at least write them down. I'm identifying the reference angle for each of these angles, and then basically I'm using the quadrant to identify the sine. And that's it. And again, I have this memorized, right? So therefore I'm just doing this off of memory. So as long as you have this and you understand reference angles and you understand the quadrants, then you're good to go. All right, so I got to figure that out. So that's pi over 3, and that's 4 pi over 3, which is in the third quadrant, so that's negative. So it's going to be a negative square root of 3 over 2. This coordinate point is all the way there, so that's the coordinate point 0, 1. And let's see, the cosine then is just equal to 0. Pi over 4, the reference angle here is just pi over 4. But I know that from that one. This is larger than a revolution, but it's in the negative direction, right? So this is basically going all the way down there. So it's going to be in the fourth quadrant with the reference angle of pi over 4. So pi over 4 is equal to reference angle, and it's in my fourth quadrant. And the cosine is going to be a positive square root of 2 over 2, because cosine is positive. And a negative 2 pi is just going to be there, which is the coordinate point 1, 0, where sine is equal to 0. All right, there we go, guys. We did 32 questions. Now I'm going to do a little bit less writing, and I'm going to do more talking and stuff in my brain, and I'm hoping I don't make more mistakes, but I kind of want this video to get going a little bit quicker for us, because I think we have 4 pages, and we just did page 1. But hopefully at least my instruction on page 1 was helpful. Now I'll try to make this to go by a little bit quicker. But some of these I still need to graph. For instance, 5 pi, I know all the way around is 4 pi. Oops, I'm sorry, I'm going the wrong way. Here is 4 pi, so that's 1 pi, so that's going to be 0, 1. Y coordinate is 1. And again, guys, a lot of times I'm just going to write these in there just because I will, I still make mistakes all the time. 5 pi over 3, like again, I was doing negative angles. So 5 pi over 3, so 6 pi over 3 is all the way around. So 5 pi over 3 is going to be reference angle of pi over 3, so that's going to equal, so once I know my reference angle, let's do square root of 3. And then that's going to be in the fourth quadrant, so therefore that's going to be negative. 4 pi is right there, so that's 1, 0. So that's going to be 1. Sine of pi, that coordinate point is negative 1, 0. So sine is going to equal, 0. All right, the sine of negative pi over 3. Oops, sorry about that. The negative pi over 3, let's see here, negative pi over 3, that is going to have a reference angle of pi over 3. That's going to be in the third quadrant, so pi over 3 is going to equal 1/2. Since it's in the fourth quadrant, it's positive. Negative 3 pi over 4, that is going to be in the third quadrant, so that is going to be positive, and pi over 4, tangent of pi over 4 is going to be 1. Negative 11 pi over 6. Let's see here. That's going to be almost a revolution. That's going to take us actually to the first quadrant. Reference angle of pi over 6. So therefore, and that's the sine, which is the y coordinate. So that's going to be 1/2. Sine of pi over 4, that's first quadrant, square root of 2 over 2. Negative 7 pi over 3, that's going to be more than a revolution in the negative direction. So this is 6 pi over 3, this is 7 pi over 3. Right, so that's in the fourth quadrant, so therefore sine is negative. So it's going to be a negative square root of 3 over 2, because again, the reference angle here would be pi over 3. In this example, the reference angle is pi over 3. This is going to be negative 4 pi over 3. So again, same reference angle, pi over 3. It's in the second quadrant though, so therefore it's going to be negative for tangent. And remember, tangent is square root of 3 in the second quadrant. The next one here, we have 3 pi over 2. So going this way, that's going to be there. That's the coordinate point 0, comma negative 1. Tangent is y over x, so therefore this is undefined. Next one here, we have negative 9 pi over 4. Again, this is over a revolution, right? A greater than a revolution. So therefore, let's see here, greater than a revolution, sine, that's going to be the second quadrant, reference angle pi over 4, negative square root of 2 over 2. You can see my brain is now starting to hurt because that was a really easy problem to be able to answer. And sometimes I advise students like do certain problems like that are very basic, like don't do the negative ones or don't do the ones that are greater than, pi to get around from those. Like that a lot of times helps you out, can make things a little bit easier for you. 2 pi over 3 is reference angle of pi over 3, and that's in the second quadrant, so that's a negative 3. 7 pi over 6, reference angle pi over 6, and that's in the third quadrant, so that's going to be negative, so therefore negative square root of 3 over 2. Sine of pi halves, that's going to be the coordinate point 0, 1, so that's 1. 11 pi over 6, let's see here, that's going to be in the fourth quadrant, so that's pi over 6, cosine of pi over 6. Yeah, that's square root of 3 over 2, and that's positive. 9 pi halves, wow, that's a lot of rotation here. So let's break that one up. So again, we can break up 9 pi halves into 4 pi halves plus 4 pi halves plus pi halves. So really, we're just finding the tangent of 0, 1. I can't believe I did that many rotations, which is going to be undefined. Negative pi over 6 is in the fourth quadrant, reference angle pi over 6. So therefore, that is positive square root of 3 over 2. 7 pi over 3, that is going to be over 1 revolution. 7 pi over 3, so reference angle of pi over 3 in the first quadrant. So therefore, that is square root of 3 over 2. Here we have a reference angle of pi over 6. Negative 5 pi over 6 is going to be right there. So that's in the third quadrant, so it's going to be positive. So that's square root of 3 over 3. Sine of negative 7 pi over 6, that's a reference angle of pi over 6. That angle is negative, so that's going to be there. Reference angle, again, pi over 6. Sine is still going to be positive, so that's going to be a positive 1/2. Negative 11 pi over 6, that's going to be almost a full revolution, but it's going to be in the first quadrant. Reference angle pi over 6, and so therefore cosine would be positive, so square root of 3 over 2. Sine of negative pi over 6, so that's going to be 0, negative 1. Okay, so the sine is just equal to negative 1. Cosine of 9 pi over 4, that's going to be cosine of 9 pi over 4. Cosine of 9 pi over 4. That's almost a full revolution. That is a full. It's over a full revolution again. Okay, so over a full revolution, but again, that's in the fourth quadrant, so that's square root of 2 over 2. I don't know why that 9 pi is like crazy. So here's a negative 1. So negative is going to take me... Did I do positive right? I didn't do positive right. Jeez, I'm crazy. That angle's wrong. That is the negative version. I hope I'm not doing these negative wrong. I keep on mixing up. Now I'm doing negative angles. So positive 9 pi over 4 is right there. The answer is still the same, but negative is right there. So make sure you address. I want to make sure that I'm doing my negatives correct. Yes, yes, positive. I think I did so many negatives in a row, I just kind of got like loopy. All right, let's go ahead and do 2 pi. So therefore, that coordinate point is 0, 1. No, it's not. It's 1, 0. So therefore, the y coordinate is 0. Negative 3 pi halves, that's going to be up there. So the tangent is 0, 1. So y over x is going to be undefined. 2 pi over 3. Let's see here. That's going to be from there, reference angle of pi over 3. That's in the second quadrant, though, so it's negative square root of 3 over 2, and that's a negative. Pi over 6, that's going to equal 1/2 in the first quadrant, so that's positive. 5 pi over 4, that is in the third quadrant, so sine is negative, so that's a negative square root of 2 over 2. 7 pi over 4, that's almost a full revolution. That's in the fourth quadrant, so tangent is negative. Tangent of 0, that is right there. That is the coordinate point 1, 0. Y over x is just 0. There you go, guys. Almost halfway done. 2 pi. So again, 2 pi is going to be, I didn't even get this far making my key. I'm pretty proud of myself. And I still got time. All right, so 2 pi is right there. So that's the coordinate point 1, 0. So the cosine is just equal to 1. Negative pi over 3 has a reference angle pi over 3. But again, it's in the fourth quadrant, right? So therefore, tangent's going to be negative. So that would just be square root of 3, but that's a negative. 5 pi halves is pi halves, 2 pi halves, 3 pi halves, 4 pi halves, 5 pi halves, right? So, jeez, I don't know why you do that to me. So that's the coordinate point 0, 1. So y over x is just going to be, again, undefined. Negative 2 pi over 3. Let's see, that's going to be in the negative 2 pi 3 is in the third quadrant, so sine is negative. For that's going to be a negative square root of 3 over 2. Sine of 4 pi, that's going to be all the way around once, all the way around twice. So again, that's 1, 0. The sine is just equal to 0. That's just 2 revolutions. Should have gone through that. Negative 4 pi over 3 has a reference angle of pi over 3, and that is an angle in the second quadrant, pi over 3 over. So therefore, cosine is negative. For pi over 3, that's going to be a negative 1/2. Negative 5 pi over 3, that is going to be in the first quadrant. Okay, because negative 6 pi over 3 would be all the way around. So that's going to be positive, and with the reference angle of square root of 3. Or I'm sorry, of pi over 3. So that's just going to be square root of 3 is the answer. Negative pi gives you a point of negative 1, 0. So the sign is just 0. Whoa. All right, negative 7 pi over 3. Let's see, that's going to be larger than a revolution, right? That's going to be all the way around is negative 6 pi over 3, so that's negative 7 pi over 3. So cosine of pi over 3 is 1/2, but since it's in the fourth quadrant, it is also going to be positive 1/2. Negative 13 pi over 6 is greater than a revolution, 12 pi, so 13 pi. That is in the fourth quadrant, so therefore sine is now negative. The sine of pi over 6 is 1/2, but in this case, since it's in the fourth quadrant, sine is negative. Tangent of 4 pi just gives us back to this point. 1, 0, 0 over 1 is just 0. 5 pi over 6 takes you there. And at 5 pi over 6, you guys can see that, let's see here, 5 pi over 6. 5 pi over 6 has reference angle of pi over 6. It's in the second quadrant, so it's negative. So it would be a negative square root of 3 over 3. Cosine of pi over 4. Oh, thankfully. Get those first quadrant ones back again. 7 pi over 6 has a reference angle of pi over 6, but it's in the third quadrant. So therefore, that's going to be negative. Sine of pi over 6 is going to be 1/2, but it'd be negative 1/2. 5 pi over 3 is going to be in the fourth quadrant. Cosine is positive in the fourth quadrant, and of 3, that's going to be a positive 1/2. Cosine of pi, that's the coordinate point negative 1, 0. That's just equal to a negative 1. Negative pi over 3, that's in the fourth quadrant. Sine is negative. For pi over 3, that's going to be a negative square root of 3 over 2. This is going to be larger than 2 revolutions, right? So we already did kind of this, like 6 pi over 3, 12 pi over 3, 1 pi over 3. So really just the reference angle here is pi over 3. The tangent of pi over 3, well, not only is that the reference angle, but the angle also ends in that first quadrant. There's 2 extra revolutions. So therefore it ends in the first quadrant, so therefore it's positive square root of 3. It's just going to be square root of 3. Negative 5 pi over 6, reference angle is pi over 6. It's in the third quadrant, so therefore it is going to be, cosine will be negative. Pi over 6 is going to be a negative square root of 3 over 2. Negative 5 pi over 4, that's going to be in the second quadrant. Pi over 4 is the reference angle, so therefore it's going to be positive in the second quadrant, and square root of 2 over 2. Negative 7 pi over 4. Let's see, negative 7 pi over 4. Negative 7 pi over 4. Reference angle has pi over 4, so I know it's 1, and that goes into the first quadrant, so therefore that's 1. I like that one. Negative pi halves, 0 comma negative 1. Tangent negative 1 over 0. Negative 1 over 0. Tangent of negative 1 over 0. Tangent of negative 1 over 0. Tangent negative 1 over 0 is going to be y over x, which is undefined. Okay, 9 pi over 4 is larger than a revolution, so that's going to take us back to the first quadrant, though. Reference angle is square pi over 4. Let's see here. This one is going to be larger than a revolution, but in the negative direction. Tangent is negative in the fourth quadrant. Reference angle is pi over 3, so that's going to be a negative square root of 3. 2 pi over 3, reference angle is pi over 3. So the sine here in this case is going to equal square root of 3 over 2, and it's going to be positive. For pi over 6, that's in the first quadrant. We did this one at the beginning, if you recall. That's square root of 3 over 3. Cosine of 4 pi over 3, that is going to be an angle that is in the third quadrant with a reference angle of pi over 3. So the cosine of pi over 3 is going to equal 1/2, but since it's in the third quadrant, that's a negative 1/2. 11 pi over 6 is, let's see, 11 pi over 6 is almost all the way around. That is in our lovely fourth quadrant with a reference angle of pi over 6 and negative since it's in the fourth quadrant. So that's a negative square root of 3 over 3. Yes. Okay. 9 pi over 2, that has a couple revolutions here, right? 4 pi over 2, done. 8 pi over 2 is just two loops around. So we have an extra pi over 2. So it's really the point 0, comma 1, so the sine of that is just 1. For 3 pi over 2, that's down there, which is 0, comma negative 1. So the sine is negative 1. Cosine of negative pi over 4, that is going to be in the fourth quadrant. So therefore cosine is positive, and the reference angle is pi over 4, so that's square root of 2 over 2. And then tangent of negative 2 pi over 3 is negative 2 pi over 3, so that's a reference angle of pi over 3. Let's see, that's a reference angle of pi over 3. So therefore tangent, though, is going to be positive because it's in that quadrant. So that's going to be square root of 3. All right, guys, last page. We're almost there. Oh, man, we're almost done. I don't think if I would have made this video, I would have been able to, finish this because I need to be, it's so boring to do this, on your desk or in your classroom by yourself. So thankfully I have you guys. Hopefully I kind of think, I'm doing it by myself, but I can try to think of you guys watching me currently, I'm live streaming or something. All right, so negative 7 pi over 6, let's see, that's over there. That's in the second quadrant, so cosine's negative. Reference angle is pi over 6, so therefore that's going to be a negative square root of 3 over 2. Negative 5 pi over 6, that's going to be in the first quadrant. Reference angle is pi over 3. Cosine is positive, so that's square root of 3 over 2. Tangent of negative 2 pi, doesn't matter what direction, you're getting back here, which is 1, comma 0. 0 over, y over x is going to be 0. 3 pi is going to be a negative 1, 0. Cosine is equal to negative 1. 13 pi over 6 is 2 revolutions. 6 pi over 3 plus 6 pi over 3 plus pi over 3. So the reference angle is pi over 3, just doing the sine, which would be in the first quadrant. So that's going to be square root of 3 over 2. 9 pi over 4 is larger than a revolution. That's going to be down there. So the tangent is just going to be a positive 1. And no, I'm sorry, it's a negative 1 because it's in the fourth quadrant and tangent is negative. So you just got to be careful with that quadrants. 3 pi over 4 is in the second quadrant. So cosine is negative, and the reference angle is pi over 4, so that's a negative square root of 2 over 2. All right, next one we have pi over 3. So the tangent of pi over 3, that's in the first quadrant, so I can just do the square root of 3. That was, again, one of our base ones that we had. Cosine of 5 pi over 4, let's see here. Cosine of 5 pi over 4, cosine of 5 pi over 4, so that's going to be here. That's going to be in the third quadrant, so cosine is negative. Reference angle is pi over 4, so that's a negative square root of 2 over 2. Cosine of 5 pi over 3, so let's see, 5 pi over 3, that's going to be back to our fourth quadrant. Sine is going to be negative. The sine of pi over 3 is going to be a negative square root of 3 over 2. Negative square root of 3 over 2, it's in the second quadrant. Good to go. Negative 3 pi over 4, that's right there. Reference angle is pi over 4. And it's in the second quadrant. So again, the answers, these two answers are exactly the same. Ah, cool. Both have the same reference angle and they're both in the same quadrant. So if they have the same reference angle and they're in the same quadrant, their answers will be the same. The sine of 0, I don't feel like, yeah, that's so weird. So anyways, the sine of 0 is going to be just equal to, let's see, 1 comma 0. So that's equal to 0. Let's go and look at this as negative 5 pi over 4. So negative 5 pi over 4, that's in the second quadrant, so therefore it's negative. And you remember the reference angle is pi over 4, so tangent of pi over 4 is 1. Second quadrant makes it negative. This is going to be in the fourth quadrant, reference angle pi over 4, so that's for it's a negative square root of 2 over 2. Let's write that a little bit better. Next one, cosine of negative 7 pi over 4. Let's see, that's going to be back into our first quadrant. So therefore, that's going to be a positive square root of 2 over 2. Cosine of negative pi is going to use the coordinate point negative 1, 0. Cosine of 3 pi is going to be down here. So that's that coordinate point, negative 1, 0. So the tangent of 3 pi is, again, y over x. So that's just equal to 0. Sine of pi over 3, that's in the first quadrant. So the sine of pi over 3, sine of pi over 3 is just going to equal positive square root of 3 over 2. 5 pi over 6, that's going to be more than a revolution, right? That's 4 pi over 2. Stop that. 4 pi over 2, and that's 5 pi over 2. So that coordinate point is 0, 1, which is just equal to 0. 3 pi over 4 is in the second quadrant, reference angle pi over 4, so that for the tangent of pi over 4 is 1, but since it's in the second quadrant, it's a negative 1. 4 pi over 3 is going to be in the second quadrant as well, so tangent's negative. This one has a reference angle of square root of 3, of pi over 3, so therefore the tangent of pi over 3 is just going to be pi over 3, but again, it's in the second quadrant, so it's negative. 7 pi over 4, that is in the first quadrant. Reference angle pi over 4, that's positive in the first quadrant, so therefore that's going to be square root of 2 over 2. The tangent of pi has a coordinate point negative 1, so 0 over 1. 0 over negative 1 is just going to be 0. 3 pi halves is down there. That coordinate point is 0, negative 1. So therefore the cosine is just equal to 0. Here we're dealing with a negative pi over 6, so therefore that has a reference angle of pi over 6, and it's in the fourth quadrant, so therefore it's negative. So for sine, that'd be negative 1/2. Negative 5 pi fourths is going to be over there, which is in the second quadrant, so cosine's negative. Reference angle pi over 4, so that's a negative square root of 2 over 2. Negative 3 pi over 4 is again going to be over here, but now, nope, sorry. That's going to be in the third quadrant. It's going to be short of pi. But it still has a reference angle pi over 4, but it's for sine, so therefore sine is equal to a negative square root of 2 over 2. 11 pi over 6 is going to be short of a revolution, so that's going to be back into our first quadrant. Tangent is positive in the first quadrant. It has a reference angle of pi over 6, and the tangent of pi over 6 is square root of 3 over 3. Sine of negative 3 pi over 2 is going to be right there, so that's point 0, 1, and the sine is just equal to 1. Negative 13 pi over 6, that's going to be larger than a revolution, right? For reference angle of pi over 6, cosine is positive in that angle, so therefore that's going to be square root of 3 over 2. Here we have an extra revolution. Extra revolution of 9 pi over 2, and so therefore it's really just pi halves, and the cosine of pi halves, 0, 1, so the cosine is just equal to 0. Negative 2 pi is again just a revolution, so that's going to be 1, 0, and the cosine then is equal to 1. And then last but not least, ladies and gentlemen, is we have negative 13 pi over 6. Let's go ahead and finish this out. Negative 13 pi over 6 We know all the way around the circle is negative 12 pi over 6. So therefore, we're just going to go an extra 13 pi over 6 here. Therefore, my reference angle is equal to pi over 6. The tangent of pi over 6 is equal to the square root of 3 over 3. But since it is in the fourth quadrant, the tangent is going to be negative. So it's a negative square root of 3 over 3. I cannot believe I did that, all 29 examples. So I'm probably going to take away a couple of these for my students to probably redo this document, because this is like crazy amount of problems that I just created, and I just did. And I'm not even sure if I did all of them. I mean, I didn't do all of them. I want to do all the ones within the unit circle, and then going with some positive and some coterminal angles as well. But either way, guys, it was a lot. But I've been doing this for a while, and I already felt faster and more efficient by doing this document. And it's the only thing I can tell my students. If you do this document, you do these problems, you will be 10 times better at evaluating the unit circle than if you were to try to like memorize and get flashcards and memorize these points on the unit circle. It comes by doing, and sometimes you got to work through the problem slow, right? I work through the first 10 questions basically exactly how I teach my students in class. And then for the next couple problems, I kind of show my work, do it a little bit quicker. And then by the end, I'm able to start doing things much faster. Now, I did still show my work. My brain was starting to hurt. And obviously, if I'm not showing all my work, I'm going to start making mental mistakes. And I might have made a mental mistake. If I did, please make sure you comment below. But I hope that this video either inspired you to get to work and start practicing on your own, as well as that you can do this stuff too. So there you go, ladies and gentlemen. Hope this helped you out, at least understand a little bit more on evaluating the unit circle. And I look forward to seeing you guys on the next video.